Hello everyone, I welcome you all to this class. In this class, we are here again to consider another important topic, and today we'll be considering this topic, homogeneous ordinary differential equation. We are still on first order ODEs, and today we want to consider this topic, homogeneous ordinary differential equation. Now, how do you know that an ordinary differential equation is homogeneous? An ordinary differential equation, x prime equals f of t comma x, is said to be homogeneous if and only if f at lambda t comma lambda x is equals to f at t comma x, and your lambda should not be 0. So what this means is that I have my ODE and I have made the first derivative the subject of the formula. Then if I make this first derivative the subject of the formula, I will now have my f of t comma x. Now, if this f of t comma x, if I replace t with lambda t and replace x with lambda x in my ODE and solve it, if I simplify and lambda cancels out, I will get I get back. If I simplify and the lambda cancels out and I get back my original expression, my original ODE, then this ODE is said to be what? Homogeneous. But if the lambda did not cancel out to get back your original ODE, then it is not homogeneous. Now I use, in this format, x is my dependent variable. Dependent variable is the one that has what? Derivative sign. T is the independent. In your exam, they can use y as the dependent. In that case, y will be having prime. They can use x as the independent. So, but the one that has that dependent variable, that derivative, of course, the highest derivative you are going to have in this situation will be first derivative. And when you have made it the subject of the formula, you will now get this f of t comma x. When you have made it the subject of the formula. So now you want to solve this. If it is homogeneous, how do you solve it? You solve it using the change of variable. So you are going to say, let your dependent variable be equals to the independent times another variable. What is my dependent variable in this format I have written? X. So I will say x. Let x be equals to, what is my independent? T times another variable. You can use v, you can use w, you can use u. I choose to use what? V in this case. Somebody can use y, because y is not in my ODE. Y is not the dependent, y is not the independent. So you can use any other variable that did not appear here. So I use v in this case. So, but the idea is that your dependent variable, you are going to say let your dependent variable be equals to independent times another variable. So now let's look at this example. We are given this ODE and we want to show that this ODE on the board here is homogeneous, and it asks us to solve it. So what is the ODE? T squared plus 3tx plus x squared dt minus t squared dx equals to 0. So this is the ODE given to us. So our work here is to show that it's homogeneous and find the solution to it. So let's write down what we have. So this is the expression given to us. This is the ODE given to us. Now we have to make this the dependent variable the subject of the formula. Now we have to make the derivative, that first derivative of the dependent variable, the subject of the formula, right? So when you make the subject of the formula, you now get your f of t comma x. But in this place, you are having dt, you are having what? The x. This x prime is just the same thing as the x dt. So how do I get the x dt? If I divide this dx by dt, I'll get my dx dt, which is x prime. So what do? I have to divide this ODE by what? Dt. So let's write. So I want to divide both sides by dt. So come here, divide it by dt. What do you have? T squared plus 3tx plus x squared minus, divide here by dt, you have t squared dx dt equal to 0. So this dx dt is same thing as my what? X prime. So I can make it the subject of the formula, right? So let's make it the subject of the formula. So how do I make it the subject of the formula? Let's move this to the other side. If you move this to if you move this to the other side, it changes to what? Positive quantity, right? So if you move this negative t squared dx dt to the other side, it will change to positive. So let's make it the solution. This implies, so I move this to the other side, I have t squared dx dt equals, then this one will remain here because I move this to the right. This one will remain here. So I have t squared plus 3tx plus x squared. So what is now remaining? For me, I'll make this the x, the t, the subject of the formula. So how do I make it? I'll divide both sides by the coefficient t squared. So this implies my dx. So if I divide if I divide here by t squared, I'll have my dx dt. So I'll make it the solution of the formula. So I'm dividing both sides by this, by t squared. So I'll divide this right hand side by t squared. I have t squared plus 3tx plus x squared, all divided by t squared, right? So of course, this implies that x prime, which equals my f of t comma x, is equal to. So remember, this dx dt is the same thing as, in short form, is the same thing as what? X prime. Same thing as x prime. So which is now equal to a function of what? A function of t and x. A function of t and x. So what is that function of t and x? This expression we have at our right hand side. Because this x prime is this, and they told us that when you have made the solution to the formula, you will get f of t comma x, which is a function of t and x. That is this expression. So this is my f of t comma x. So I have created space, but we know what we are going to check if you want to show that this is homogeneous. Because in our question they say that we should show that it's homogeneous, and we should what? Solve it. We should show that it's homogeneous and solve it. So this is my f of t comma x. From my previous explanation, I told you that it is homogeneous if f at lambda t comma lambda x, if this is equals to f at t comma x. So this is what I wrote earlier. This is what I wrote earlier in my explanation. If this f at lambda t comma lambda x is equals to f at t comma x, then it is homogeneous. This is our f at t comma x. So let's do f at lambda t comma lambda x. Let's do that one and see what it will give us. Now, okay, now f at lambda t comma lambda x equals, so this f at lambda t means in this your f of t comma x, replace t with lambda t. So this place we're having t squared, instead of t squared it will be lambda t all squared. I'll replace t with lambda t plus, so instead of this place we're having 3t, so what we are going to have is 3, the t will not, you are going to replace that t with lambda t. It will be 3 lambda t. Then this place you are having x, you replace x anywhere you see it by what? Lambda x. So instead of this x, I'll write lambda x. The next one we have is plus, we have x squared. You replace x with what? Lambda x. So instead of x squared, we have lambda x all squared divided by, we are dividing this by t squared. So instead of this t squared, what will I write? Lambda t all squared. So I have lambda t all squared. So this is equals to what? So square this quantity, square both of them, have lambda squared t squared plus multiply lambda, you have lambda squared. So I have 3 lambda squared tx plus square both of them, lambda squared x squared divided by square both of them, lambda squared t squared. Wow, that's wonderful, right? Next thing is to simplify, right? Okay. Now, this lambda square at the denominator, what will cancel it is what? If we can factor lambda square at the numerator, it will cancel this lambda square at the denominator. Okay, let's check. Lambda square is here, lambda square is here, lambda square is here. So all the terms at the numerator has lambda square. So we can factor it out. So this implies, so let's factor lambda squared into, so if I factor lambda squared, I'll have what is remaining here is t squared plus what is now remaining here is 3 tx, and what is now remaining here is x squared, then divided by lambda squared t squared. So what will happen? Lambda squared cancels lambda squared. So that's nice. So this is equal to what? So what do you now have? You now have your t squared plus 3tx plus x squared divided by what? T squared. But what is this expression? This expression is my f of t comma x. Wow, I've shown that it's homogeneous, right? So we are going to make that statement. Therefore, it is homogeneous. Wow, wonderful. It is homogeneous, right? So it satisfies it. Since f at lambda t comma lambda x equals f at t comma x, so they are equal. So because we simplify, lambda cancelled out, we got back our original expression. Okay, let me call this our expression here. This one where we made x prime is such to the formula where we got f at f of t comma x. So I will call it equation 1. So let's call it equation 1. So we now solve. Now, so we want to solve it, right? Now let what do I say? If you want to, what's the change of variable? Change of variable is what? Your dependent variable. You are going to say let your dependent variable be equal to the independent times what? Another variable, right? So that's the change of variable. You are going to say what? Let your dependent variable. What is my dependent variable in this ODE? The one that has prime. Which one has prime? X. So x will be equal to what? What is my independent? The other variable will become the independent. What is the other variable? T times another variable. Okay, v. I choose v in this case. So I have this. So let me call this equation 2. So it means in this expression, anywhere I see x, I will replace it with what? T times v, so that I will be able to solve it. Now what is now remaining is what? I need to get this x prime, so that I can replace x prime too and write it in terms of my v and t. So how do I do it? I will differentiate this. So x prime will be equal to, what is the derivative of this? Now since you are replacing this v, since this v will replace x, so this v will also depend on what? T, because x depends on t. So this v will depend on t. So this is just like v of t. So this expression, this x equals tv, is same thing as x equals t v of what? T. So that's v2 will depend on t. That's this thing I wrote. Now how do you differentiate product of two functions? You use what? Product rule. So what do? I differentiate t and keep v. If I differentiate t, what will I get? 1. Multiply the v I'm keeping, I have my v plus. You now keep t and differentiate v. How do I show that I have differentiated v? I will just put what? Prime on v. Then I'm keeping t. So what will I have? T v prime. Wow. So let me call this one equation 3. So we can substitute this equation 2 and equation 3 in our equation 1, because we have gotten x prime in terms of t and v, and we have gotten x in terms of, we have written x in terms of t and v. So we will be able to solve it. Substitute equation 2, equation 3 in what? In 1. So let's substitute. So this implies, so instead of this x prime, what will we will replace it with what? V plus tv prime equal to, so what do I have here? At the right hand side, I have t squared, right? Plus, what's the next thing I have? 3t, then x. Instead of writing x, what will I write? X is tv. So instead of writing x, I'll have what? I'll write tv, right? Then what is the next thing? Plus, instead of this x square, what will I write? tv squared, tv all squared. So I have tv all squared because that's my x divided by t squared. Okay, so this is what the one we'll be working with, right? This is what we'll be working with. So let's clean here. We can clean here. So this implies what? This implies v plus tv prime is equal to t squared. Now t multiply t, what will you have? So we have t squared. So altogether we'll be having, because we're having t times t here, you have t squared. So we have this 3t squared v plus, if you square this two quantities, square t, you have t squared, square v, you have v squared, divided by what? T squared. So what do you notice? T squared is here, t squared is here, t squared is here. If you bring it out, what will happen? It will cancel this word t here. So let's just, this implies we'll have our v plus tv squared, we'll have v plus tv prime equal to, let's factor t squared into 1 plus 3v plus v squared, all divided by t squared. So clearly they will get cancelled. What will you have? This implies that v plus tv prime, which is what we'll have at the left hand side, is equal to, what will we have at the right now? 1 plus 3v plus v squared. So well, that's what we have. This implies what? You are going to make this, the one that has derivative sign now, this v prime, the subject of the formula. So I'll move this v to the right. So I'll have tv prime left at the, that's what I'll have at the left hand side now, because I'll move this v to the right to change to negative. So let me first of all write what I have at the right hand side. I have 1 plus 3v plus v squared. So if I move this v to the right, change to negative and negative v. So this implies tv prime equals, so let's subtract 3v minus v, what will I have? 2v. So I'll have 1 plus 2v plus v squared. What's the next thing? We can make v prime the subject of the formula, right? Let's divide both sides by what? T. So this implies my v prime is equal to 1 plus 2v plus v squared, all divided by what? T. Now, if you are solving homogeneous ODE, if you have done your appropriate substitution and you have reached to this stage, you are going to do or solve this expression using your separable method. Now this v prime, separable method is, you are going to separate the two variables. So you are going to separate v and t. You can move v to the right hand side and leave all the expression of t at the right hand side, right? So this v prime, I'll write it as what? dv dt, because I will also separate the v and separate the t. So when I have separated v, everything about v and the v at the right, at the left, and I've separated the t and the t at the right, so I can integrate both sides. That's the idea. So this will be equal to what? So I want to separate this t and this. So how will I write it? I can write it as 1 plus 2v plus v squared enclosed in a bracket, right? Enclosed in a bracket, multiply by 1 over t. This is how I can write it. So I want this dt to come to the right. So what do? I will multiply both sides by dt. So this implies, so if you multiply both sides by dt, multiply here by dt, I have dv equals, multiply here by dt, I have 1 plus 2v plus v squared 1 over t dt. The next thing is we want to separate this. So what do? I will divide both sides by what? This quantity here. If I divide both sides by this quantity, I will now have 1 over t dt at the right, and I will now have all the expression of v at the left hand side. So this implies dv divided by 1 plus 2v plus v squared is equal to 1 over t dt. So I have divided both sides. So everything about t is at the right, everything about v is at the left. So what do? Integrate. So you integrate both sides. This implies integral of dv divided by 1 plus 2v plus v squared equals integral of 1 over t dt. So we'll integrate both sides. So now this implies what? Now what do you notice at the denominator here? For you want to integrate this, what do you notice at the denominator here? You are having a quadratic expression. So what do? You can factorize it. You factorize it, if it is the expression, you can split into partial fraction, you do that, so that you'll be able to integrate. If it's something that you use another method to do that, to integrate, you do that. So but what is the factorization of this? Looking at this, it's looking like expansion we know. This is just looking like v plus 1 all squared, isn't it? So if you expand this v plus 1 all squared, you get exactly this, right? So now this I'll write this as integral of dv divided by, okay, let me shift dv this side, so I will now have 1 at the numerator. Then this expression I'll have v plus 1 all squared. That's the factorization of this. Then dv, right? They are the same thing. Just shifted this dv here. So equal to, what is integral of 1 over t? Now if you differentiate, what is down here is t. If you differentiate t, what will you get? If you differentiate t, you get the numerator. What is the numerator? 1. Because if you differentiate t, you get 1, which is exactly the same thing you have at the numerator. So the integral of this fraction, this rational function, will be the ln of the denominator. Ln of what? T. Then I'm going to put the constant of integration, c. So this quantity, I can write it as something. I can use the law of indices, right? I can use the law of indices here. So this simply implies integral of, I will remove this fraction, this 1 over, introduce negative on the index. So I have v plus 1 all raised to power negative 2 dv equals ln of t plus c. Wow, I think it's interesting. Now, how do I integrate this stuff? I can think of shortcut. So I want to use shortcut here. So now, if you want to integrate a quantity which is enclosed in a bracket and raised to a power, so if you want to integrate it, what do? The shortcut is if you differentiate the inside, remember you are integrating with respect to v. So if you differentiate the quantity inside with respect to v, if you differentiate this quantity side, if you differentiate 1 you get 0, differentiate v you get 1, right? So the derivative of the inside is 1. Now that one we got is what? A constant. There is no v there. If there is v in the derivative of the inside, then this shortcut will fail. But if the derivative of the inside is giving you a number only, just a constant, and this shortcut will work. So I will use that answer I got to divide this whole quantity, v plus 1 raised to power negative 2. But in integration, what do? You are going to add 1 to the power plus 1, and you are going to use the result to divide this quantity. So I'll bring down the power here, denominator. If I bring it down, it will multiply the result I got in the derivative of the inside. So negative 2 plus 1 will give me negative 1. So I'll bring it down here. It will multiply this. Wow. So this is what? So this will give me, in bracket, v plus 1 raised to power negative 1 divided by negative 1. So by the law of indices, I can return this to fraction by removing this minus sign. Right? By removing this minus sign, I'll get what? 1 over, because of this negative I have down here, to negative 1 over v plus 1. So that will be the integral of that. So this simply implies this integral here is negative 1 over v plus 1. So it will be equal to, so what do we get here? Ln of t plus c. So we have done the integration. So we are going to, v has helped us to solve this ODE, and we have done the integration now. So we are going to return our dependent variable. So let's write, but from equation 2, right? V x equals tv, but from equation 2 we had that x is equals to what? Tv. So which implies that my v will be equal to x over t. So this implies what? So I'm going to replace v with what? X over t. So this implies negative 1 over x over t plus 1 equals ln of t plus c. So I'll replace this v with x over t. So now I can solve this expression. So this implies, so what is the LCM of this? 1 is same thing as 1 over 1, right? Okay. So let me write what I have at numerator here. I have negative 1 over. Then let me solve this fraction down here. My LCM is t. T divided t, I have 1. Multiply x, I have x. Plus 1 divide t, I have t. Multiply 1, I have t. So equals what? Ln of t plus c, as we have at the right hand side. So this is just reciprocal of a fraction. If you have 1 over 2 over 3, this means this is reciprocal of this fraction. The fraction is 2 over 3. You are doing the reciprocal. So what will happen is what? Your denominator will become the numerator, and the numerator will become the denominator. So this fraction reverses. So instead of 2 over 3, you now have 3 over 2. So the same explanation holds here. So instead of t being at the denominator, t will be at the numerator. But because of this negative here, we are going to have negative t divided by, then we will now have x plus t. So this will be equal to ln of t plus c. So this is the result we got in the solving of this problem. So thank you so much for being part of this class. See you in our upcoming class. Bye.